Hey folks, Dan here. Today on the Microarch Club podcast, I am joined by Kay Lee. Kay is the CEO of SiLogy, which is a YCombinator backed startup building a collaborative CI/CD platform for integrated circuit design verification. Kay has had an interesting journey to working on hardware and eventually founding a company. We begin in North Florida, where Kay grew up and fell in love with mathematics. This takes him to the University of Chicago, where in addition to math and computer science, Kay studied finance and was exposed to the local high-frequency trading industry. Kay offers a unique view into the use of specialized hardware in high-frequency trading and describes why FPGAs have become popular in the field. However, despite their effectiveness in latency-sensitive operations, the development workflow for FPGAs has remained cumbersome and inefficient. Kay's own first-hand experience with this process led him to start SiLogy with his co-founder Paul Kim. The latter part of our conversation focuses on Kay's vision for SiLogy and how the FPGA and ASIC development process can be improved by borrowing from the workflows we have come to expect in software development. We also walk through the process of applying to YCombinator, discuss what it takes to start and run a company, and talk about how the rapid rise of AI workloads could lead to a rise in the number of chip companies. One of my favorite parts of hosting the Microarch Club is having the opportunity to talk with both folks who have had a huge impact on the field of processor design and those who are in the earlier stages of their journey to doing so. When talking to Kay about SiLogy, I can't help but wonder if 50 years from now someone will be hosting a podcast and talk about the company with the same reverence with which I refer to historical EDA companies like Daisy Systems and Mentor Graphics. Either way, Kay and team will be part of the story, and I'm excited that there are still folks like them interested in pushing the industry forward. With that, let's get into the conversation. All right. Hey, Kay, thanks for joining today.
Yeah, it's good to be here.
Awesome. Well, I'm super glad to have you on the show. I've had a number of different folks from different backgrounds on the show, both folks that have kind of worked in the industry many years ago and are now maybe retired or at the latter stages of their career. I've had a few folks who are working in startups today and kind of on the more modern side of the industry. And I think you certainly fall into that category. And one of the things I really like is kind of comparing and contrasting those different experiences. So I think we'll have a lot of fun maybe learning how you've been inspired from folks in the past and developments in the past, but also learning about maybe what the work you're doing today is going to bring to the industry as well.
Yeah, sounds good.
Awesome. Well, if you've listened to the show at all, you know that I like to start with getting kind of folks' background. And I'd love to learn kind of what your introduction to computing was, and maybe kind of like how that shaped the path you went on, starting in your childhood.
Yeah, I mean, like, I didn't have like an extremely intense background with computing growing up. Like my parents always had like a computer growing up, and my dad actually did research on like numerical analysis. So I remember at one point when I was in like middle school or something, I asked like if he could help me like learn how to program, and then he showed me Fortran.
Okay.
And I think that kind of ended my exploration at that point for a little bit.
Sure.
And so yeah, I mean, like I've always just like been like goofing around on the computers. A lot of it was just like doing like HTML stuff or just like web-based things, like nothing too elaborate. And yeah, those were my early memories working with computers. Mostly I was just focusing on doing math, and that's like what I went to college for. And I kind of did like some of the computer programming stuff a little bit later on in college. Yeah.
Gotcha. Do you remember what your first computer was, or the first machine y'all had in your house?
I don't. Oh man, I think it had like all I remember is like I think it had an Intel Pentium 3 processor. That's the one that I actually remember.
Okay.
Using with any regularity. And I remember when processors started getting like above like 1 gigahertz and then like quickly above it, I was like, my mind was blown at that point.
Sure.
Know? Yeah. I don't know. It was great. I mean, like things changed like so quickly during those times, and I think that's I mean, that obviously propelled a lot of innovation forward because you could just like wait a year or two and then like clock speeds would be like so much higher. I don't know, like your processors would be like so much better.
Right.
And then I went from like floppy disks to like CDs to DVDs and like all that kind of stuff and like flash drives. I don't know. It was a really cool time. Yeah.
Awesome. Was the kind of like education environment you were in? This is one of the things that's kind of come up on the show a few times. Was there a emphasis on computer science, or was that not something that was really expected to be studied in kind of your high school and middle school environments?
Yeah, not at all. Yeah, I mean, yeah, so I grew up in Northwest Florida.
Okay.
I was kind of taught by like, you know, like riverboat gamblers and like itinerant preachers, like that kind of thing. So, yeah, it wasn't like I mean, I had a pretty good education in some ways, but it definitely wasn't like high tech. Yeah, like a lot of that stuff I just had to like figure out on my own. Yeah.
Gotcha. And you kind of gravitated to math there. You said, well, how did that manifest in high school? Were you kind of like getting involved in math competitions and things like that, or was it more of just like within school that was your interest?
Yeah, I did a ton of math competitions, and I took a lot of like math classes at the University of West Florida, like
Okay.
after school hours. So like, it started in the summers, like, starting in like fourth through fifth grade. I would just like audit like some random math classes where my dad would let me, and then eventually I started taking like more advanced math classes, and that's just what I really liked. And it's very beautiful because like you can just do it with like a piece of paper and a pen and in like a book, and so you can just like learn a lot. And it's fun like just like flipping to the end of like a book to see like what I will have learned after a certain amount of time. So
Right.
I still like to do like math stuff every now and then. Not with any seriousness, but like it's all something that like I hold dear within my heart.
Absolutely. And you decided to go to University of Chicago, I believe, which is a great
Yeah.
school. And I think you studied math there. Was that kind of like a natural transition? Obviously, this is the thing you're interested in. U Chicago's, good in that department. Was it just kind of a seamless transition into college?
Well, yeah, I mean, I wouldn't call it seamless. I mean, I basically wanted to do math the entire way through. Um, yeah, I mean, math is like, I mean, it's very beautiful, but it's also like very difficult. And I learned fairly early on that I was never going to make it as like a mathematician. I was just being outclassed by like, a lot of my friends at the time. I took like a notoriously difficult math class and I actually stuck through all three quarters of it. We were on the quarter system. And, yeah, but I basically realized that I wasn't going to cut it as like a math person, so I had to like try to figure out like what else to do. And like that was a bit of like a ego disappointment or something, but the scars of which I carry to this day. But yeah, but it was good to figure that out sooner rather than later because I know a lot of people who continue to do math and then were just kind of like tortured by it for the rest of their lives. I've only been tortured by it for most of my life.
Right, right. Fair enough. So when you kind of decided or realized perhaps that math was not kind of the professional path, at least purely math, right? Where did you kind of start to look in terms of what kind of profession or what you might want to get into after you graduated?
Yeah, so my dad's a professor, so he naturally wanted me to be a professor as well. And my sister like went to graduate school for accounting. She got a PhD in accounting from MIT, and so academia was like the obvious route. So then I kept taking math classes because like that usually impresses people, and I was gonna try to do maybe economics, maybe like finance, like one of those things. Towards the end of my time, though, I kind of realized that I really did not want to go into academia. And so that's how I got into finance, basically. Is like what requires like a lot of math, and what could I like I don't know. Yeah, it pays better than grad school, so
Right.
I could try to figure that out for a little bit of time. I did take some computer science classes in college. Mostly, I mean, discrete math, which has math in the name, so that kind of barely counts. Algorithms, which was taught by like um, Laszlo Babai, who's like this like great like theoretical computer scientist who like invented instead of turning it into like something where you like write depth first search in like Python or something, he turned it into something where you ended up doing like these like proofs related to like whether or not something's NP complete, like what stuff like that. So that was
Hmm.
fun too. But then I did functional programming, so in Elm, which was honestly a lot of fun.
Yeah.
And yeah, Yeah, but then I eventually worked my way over into finance.
Gotcha. And being in Chicago, one of the previous guests I had on the show is Matt Godbolt, and he
Oh
works
yeah.
in trading in Chicago. And I had a kind of a bit of a personal experience going to university in St. Louis, and then going
Hmm.
up to Chicago. I was kind of the computer science finance kind of track as well. Was it kind of like that was the natural thing to do to get into trading if you were going the finance route, or was that something that came along after kind of deciding to study finance?
Um, yeah, so I kind of continued studying like math and a little bit of computer science and like some economics, just like not really knowing what was like I wasn't very career like minded at this point. Um, but yeah, I remember like talking with like a corn trader who like would trade in the pits at like the CME.
Hmm.
Even in like 2000 like 12 or 13, whenever I met this guy, like it seemed kind of old fashioned at the time. And then yeah, and then I just like knew it. Yeah, and then it just like applied to a bunch of different places. Oh, a funny thing is that I took like a class at the boot school with like it was called like market design, I think, and or like mechanism design and something about this. It was taught by this professor Eric Budish, who wrote a very famous in finance, like in academic finance, like a paper on high frequency trading, the high frequency trading arms race.
Okay.
Uh, Trying to quantify like how much money is like kind of being accumulated to these like latency games and stuff. And he, and then this was also when Flash Boys came out, roughly. So I remember reading Flash Boys. I remember taking this class, but I think I took the wrong lessons from the class. I got a good grade, but like I took the wrong lessons and I decided that like high frequency trading is actually it seemed really cool.
Right.
So yeah.
Was the class kind of trying to make a case against it not providing a lot of value to society, or was it actually encouraging the like thinking it
Uh,
was interesting?
I think so. The class was like more broader focus. There was like a lot of things in like this like um, specific field of like mechanism design that were really interesting at the time. But yeah, I mean, Eric Budish's work, I think, tries to argue that it's this like continuous time matching of like people was like market participants was like inefficient,
Mm.
and that like it could be solved if you just like had like batch auctions. If you just like had auctions like basically every like 100 milliseconds or so, because then like the latency edge that you get is like becomes lower, so you don't have to like worry about competing on like nanoseconds.
Right, right. That makes sense. So you get interested in high frequency trading.
Mm-hmm.
Um, what was kind of the next steps from there? How did that actually kind of like manifest in what you did next?
Yeah, so I applied to like a lot of different companies, and then I eventually started working at like a really small trading shop in Chicago. It was like around like 12, 13 people at the time. So really more of like a startup-y type of environment than, your Citadels, your HRTs of the world, right? I thought I didn't really know anything, so it would be good to like get exposure to like, or get a lot more I don't know, like attention or something.
Hmm.
So I started off as a quant, and I realized pretty quickly that I was a terrible quant because whenever I did, one problem is that like uh, you, one really bad feature for a quant or a trader to have is not losing is really not enjoying losing money, right? So I really hated whenever I saw my strategy like lose like I don't know like a few $1,000s or something like that. I would like agonize over like the fact. Like whereas like the entire game is like a statistical one, so you have to like take the ups and the downs, like right. So that wasn't so I didn't cut it very well as a quant. But the good thing about working at like a small firm is that they can there's usually like a bunch of fires going off at like any given time. So uh, I did like programming, and then I had learned like C++ and Python at this point.
Hmm.
So then eventually I started doing more C++ stuff, and then eventually I got into FPGAs because that was like the new hotness in high frequency trading at the time. So that's like that's how I got started with chips essentially.
Gotcha. And what year was this, or what time period was this in?
It's roughly like 2016.
Okay, okay.
Yeah,
And
people are still using FPGAs people had been using FPGAs at that point in time, but like there's still like a small trading firm in Chicago could find like little latency latency games that they could win at. Yeah, to
Gotcha.
make money.
And so even for like a small, company like you were working at that point, there's
Mm-hmm.
hardware specialization that's going on. Is this pretty much like across the board if you're going to play in this game, is having custom hardware or at least, reconfigurable hardware in the case of FPGAs and running all your own servers, is that just kind of like table stakes to even participate?
Yeah, I mean, if you want to be a participant on some of these latency games, definitely. I mean, it depends on like what type of like strategies you're trying to run, but yeah, like custom hardware at this point is like table stakes. And you can go through like the major training companies and look at their job postings. Like they all have like needs for like FPGA or ASIC engineers.
Right. And so, had you had any exposure to FPGAs at this point, or were you just kind of, in this job or internship, and, kind of introduced to this magical new concept of reconfigurable hardware?
So I didn't really have any experience with FPGAs before. University of Chicago is very famously a very theoretical place, so there's no like FPGA theory going around. So they didn't really
Right.
have any of that happening at the time, as far as I know. I remember like during Professor Budish's class, like he would talk about high frequency trading like for a lecture or two, and one of the murmurings was about like how like some trade show they were like, oh yeah, there's like this custom hardware that you can use to trade, so you don't even have to go through like software at all. And he was like, wow, that's crazy, So yeah, that's all I knew. But the good thing about working at a small company is that even if you're not like a subject matter expert on this thing, you can people will give you time to just like try to figure it out in
Right.
order to uh, yeah like in order to just like see what you can get done. I mean, there are negatives, which is that like you're just kind of on your own like trying to figure things out, right? You don't get like the best like instruction, but it is good because like you get exposure at least. Yeah.
Gotcha. And what were some of the first things that you configured an FPGA to do? Like what was your kind of hello world for FPGAs?
I mean, one of them was just like a faster feed. So like yeah, like CMU famously has like this like really like huge like insane message format with a lot of information on them, but like you really only need like a certain like parts of it. So in order to just like improve like throughput throughout your like trading system, you can just like both read it quickly and then just like transfer like the important data to different parts like much more efficiently. So that was one. And then there was just like a lot of like trigger based trading, which is what yeah, like we did a lot of that. So that's what actually started making the money. It was like, there was like some event on one symbol, and then like we could trigger like a trade in another symbol, or sometimes the same symbol. Yeah.
Gotcha. And was that all happening in the FPGA in the trigger based case, or was that?
Yeah.
Yeah, it was.
Yeah. Yeah.
Gotcha.
There's no software interaction at all. Yeah.
Gotcha. And how often is the kind of like reprogramming of these strategies taking place at the kind of like edge there with the FPGAs?
Yeah. I mean, reprogramming it. Yeah. So I guess like you don't reprogram the image that often, I would say. Usually what happens is that you have like a certain firmware image and you have like a software process that like is like kind of the buddy of it, so that, the software actually tells like the hardware, if like this symbol ticks up by like 3, right, then trade on this other symbol at this price or something, right? So that's like it programs the triggers into the FPGA, and the FPGA will use like a very simple logic to run through them in order to like see like what to trade.
Gotcha. Gotcha. That makes
Yeah.
sense. And were you writing most of your RTL in Verilog at that point, or did y'all have any alternative languages that you were using?
Most of that was just like straight Verilog, and I got into like the verification side of it just because I was writing like a C++ test bench for like PostSynth. So yeah, like yeah, basically after like we have a firmware image, like we have to like test it with like some real data, but also some like fake data in order to make sure that like when things don't go through like software at all, you have to be very careful with like the risk
Right.
profile of that, right? So that's why verification is super important in trading, because you can send orders very quickly, but that could also mean you could lose a lot of money really quickly.
Right. Can you kind of talk through what verification looks like in FPGAs? Obviously, this is going to be relevant kind of later on in your path as well, but just kind of like from a first principles perspective, what is verification in FPGA or logic design in general?
Yeah, I mean, verification is basically, does the chip do the thing that I expect it to do? Like given like some higher order model of what the chip is supposed to be doing. So that could be a design document. It could be like a model that somebody writes in a different language, like Python or Scala or something. Um, you know, but basically, chips are highly complex, like parallel systems, right? Like, software engineers love complaining about like, oh, they had to debug this like multi-threaded, like, yada yada. But like every clock cycle, like a million things are happening on a chip.
Right.
So you can imagine that it becomes like the complexity of like trying to debug that is like very difficult. And also like whenever you program in FPGA, there aren't a lot of great ways to just like see what's going on inside. You can't just like slap on GDB and like let it rip. So you have to do a lot of stuff before, like pre-synthesis. So, you know, and you could have, so let's say you have like a chip for trading or something, right? There's a part that does like the parsing of the messages, right, that you get from like a certain exchange. It's in some format. You have to extract like the price and the size data from it, let's say, right? Then you have like another part that's like a trigger-based part, which like takes the price and size of like a trade, let's say, and then compares it, like it runs through like some stuff in memory to see like if it should fire, right? That's another part of the logic. And then it could maybe fire like multiple things at like a given time. It might have to queue up some messages, all that kind of stuff. All these things are happening. That logic is running every clock cycle. So you have to be sure that you tackle like every edge case. You have to make sure that there aren't any like crazy race conditions. Because like you could, let's say you have like two Ethernet ports, right, that are both receiving trade information. You don't want like and the messages can be replicated on like both ports, right? You want to fire on like the first one, but you want to make sure that like if the second one comes in, maybe it even happens on the same clock cycle, you're not like double firing, or there are all sorts of like weird like edge cases that can come about, right? So that's kind of like a simplified view of like what FPGA verification is about. And like you can get as like like your test benches, which are these like ways of just like testing like different subcomponents of like the system. They could be like really small. It could just be like there's like a messaging protocol between two blocks on your chip, or it can be very complex. It's like an integration of like multiple blocks working together to make sure that like there's nothing that goes awry there. And it takes an enormous amount of time and effort, and that's why there are like FPGA verification engineers and ASIC verification engineers who spend their entire time just like grinding out tests, going through test cases, doing constrained randomization. You're running through random seeds constantly because like maybe if you get like a size that's like sort of problematic, or like all sorts of things can happen, or like all ones or all zeros, or like some like weird pattern that happens, like maybe like the chip will behave in like a way that you don't expect. So you have to run a bunch of random seeds. You have to go through, see the test failures, see why they failed. And yeah, I mean, it's very onerous.
Right.
Yeah.
Right. And there's kind of like a few different vectors of optimization, right? When you're working with FPGAs, and that like there's, correctness, of course, which is kind of what you're speaking to there. But then there's also, your utilization of logic elements on the board, which is, fundamentally physically constrained. There's also cycle times, which, you're going to, if you're doing more in that clock cycle, right, you're eventually going to start bumping that clock cycle out and out. What's kind of the process for balancing those various constraints that you have? And did you run into that much in trading, or were you all mostly using like pretty beefy FPGAs that could handle whatever logic you were throwing at it?
I mean, we use pretty beefy FPGAs, but like, I mean, mostly we're trying to. I mean, most important is correctness, right? You want to make sure that like whatever you get out is correct. There's huge risk involved, and you want to make sure that things are like down pat. But latency is obviously super important, so you have to tighten up like certain paths, or like make sure that if you're going to add pipelining, it's like on a non-critical path, stuff like that. And yeah, I don't know. It does get pretty complicated, but ultimately, what's important is that like it actually works, and
Hmm.
it fits like a certain latency profile, and you can do all sorts of like little tricks in order to like try to fit things in. Um, yeah, like in a certain clock cycle, but yeah, yeah. But that's kind of why at a certain point you need ASICs, right? Like if your latency if latency is important enough, you start like getting into like actually taping out a chip. Because FPGAs, no matter like how many tricks you can do, right, they'll never be as like fast as an ASIC, right? Because you have to go through all this programmable, all these LUTs and stuff. So
Right, right. And so, did you ever were you ever exposed to ASICs in the trading space, or was that mostly just like y'all didn't get to that point? You weren't actually ever taping out chips.
so when I was at Hudson River, well, I'll say that at like Hudson River Trading and a number of other like companies, they have like ASIC verification engineers and ASIC um, engineered like job postings. So taping out a chip in hyperbusy trading is like pretty common, I would say, at this point.
Gotcha, gotcha. Makes
Yeah.
a lot of sense. So you were kind of at this smaller trading shop, right? And then you eventually ended up after university going to Hudson River. Is that right?
Yeah, yeah.
What was that kind of decision like? Did you just want to have a larger experience, or how'd you end up there?
Yeah, I mean, things kind of working out that well at like the company that I was with in Chicago. That was part of it, and the second part was just that I, I'd gone to school in Chicago. I lived there for a few years afterwards. I kind of wanted to try something different. So I was looking at a number of different jobs at the time, and HRT, like Hudson River Trading, has like a really good reputation. They had I interviewed there. I really liked the people that I interviewed with and talking to, and they had a really nice office at the time. Well, they still have a really nice office. They had a really nice office, and yeah, I don't know. It kind of just like worked. It was interesting work. They did a lot of stuff with like open source, uh, tools for like chips, and I thought that was really cool. So it felt like a pretty natural pairing.
Gotcha. I feel like the FPGA space is one that is, pretty much reliant on proprietary tooling.
Yeah.
As you mentioned, there are some open source tools, and I think more and more there is more open source tool chains. But fundamentally, a lot of times when you get down to the bit stream, you have to rely on proprietary tools. What type of tools were you using in this environment, and did you find them kind of like adequate or better than adequate at the task you are trying to do?
Yeah, so at HRT, we used a lot of Verilator and CocoaDB. So Verilator is like an open source simulator. Some people would disagree that it's actually a true simulator or whatnot, but that's neither here nor there. And then CocoaDB is like a Python library that's like simulator agnostic, where you can write test benches in Python. And yeah, and uh, yeah, they use a lot of both of those. And then there's actually a really good blog post written by my old boss, Todd Strader, on like how we use those tools, or how we verified hardware at HRT. And yeah, they were pretty good. I mean, like they for FPGA workloads especially, I thought they worked pretty well. But the only problem is that when you get to like larger designs, sometimes like the performance would drop off pretty drastically. One part of it is just like the way that we wrote our test benches. Another way is just like when you're introducing Python into something, it's automatically going to slow down. And Verilator had some issues with scaling. Um, yeah, like it didn't really play very nicely with the larger designs. And it's very fast for like smaller designs, and you don't have to worry about licenses. And you can run a bunch of tests in parallel, which is like what made it very attractive. And you can also like spec the code because it's open source, right? So you can inspect the code, you can see like you can fix bugs, you can upstream them, that kind of thing. But towards the end of my time there, I worked pretty much entirely on like Verilator and CocoaDB issues, trying to make sure that we could run as many tests as fast as possible.
Gotcha. And what's kind of the thing that would you mentioned that some folks would not consider Verilator a real simulator or a full simulator? What would be the distinguishing factor between it and maybe some of the proprietary options that are alternatives?
Yeah, so one of them is that in order to get faster, it's like a cycle-based simulator. So most simulators are event-based simulators, and so it does like these like, like some would argue that's like kind of a hack in order to just like get as like yeah. So like certain things with like delays like don't work in Verilator. I think they're starting to change that. Certain like language constructs like aren't supported as well. Uh, there's an issue with also with encrypted IPs. So if you buy like verification IPs from people, or like if you buy IPs from a third party vendor, they're not just going to give you like the raw source code and stuff. So you have to like have a way of like simulating the design with the IP, and for that like Verilator just like has no answer for it. So that's like one big pain point that a lot of people have. It's also not a 4-state simulator. It's just a 2-state simulator. Just zeros and ones.
Mm-hmm.
But in a lot, you can catch a lot of bugs with like X's and Z's and like whatnot. So yeah, I think there's some other stuff there that people don't like about Verilator as well. It doesn't have mixed language support, as far as I know. I think it's just only supports like System Verilog and Verilog, no VHDL. Yeah, so I thought if you have like a Verilog only code base, like it's pretty great, and like you have small enough designs, and you can like work around some of those other issues. But yeah, for the most part, if you work at like a large chip company, people aren't doing everything in Verilator. And even at HRT, we use proprietary simulators when we ran into some of those issues. Yeah.
And so would you usually use Verilator as kind of like it's just pre-synthesis verification, right? And
Yeah.
so would you do the Verilator verification, and that would be kind of the improved development workflow and that sort of thing, and be able to get quick iterations on that, and then you go through synthesis and do post synthesis verification as well. And was that with proprietary tools?
We had like our kind of own like lab testing environment that would do post synthesis stuff. For the Verilator, yeah, like the attractive feature of it was that you could run like a bunch of tests in parallel because you didn't have to worry about like licenses, right? So we could spin out like each developer could spin out like tens or hundreds of thousands of tests like with the press of a button. And that was pretty nice. Just like distribute it out to like HRT's like a compute cluster, and then get results back really quickly. That was a really nice feature that you couldn't really get if you just only did proprietary simulator stuff. But yeah, like before we would ship an image, we would have to run some stuff through like a proprietary simulator, depending on like what project people were working on. Sometimes you could just get by with just like the Verilator CocoaDB stuff because there's enough confidence in like some of the other components, or just enough confidence in the components that of the testing that was already done. So yeah.
One of the things that you mentioned was the encrypted IP blocks,
Yeah.
and for folks that are not familiar with FPGAs or ASICs or things like that, it can be kind of surprising the way that I think IP works in these various scenarios. Like if you come from a software background, you might be familiar with integrating, open source libraries, or, in some cases, less commonly now, proprietary libraries. But proprietary IP is extremely common
Yeah.
in logic design. What kind of percentage of designs that you've worked on have been made up of proprietary or pre-built IP designs that y'all weren't actually developing yourself?
Yeah, I think yeah. So I mean, in the industry, like selling IPs is like a huge like profit driver for like a lot of different companies. A lot of companies, their entire business model is just like selling IPs, right? Yeah, like that's just like the standard in hardware. For HRT specifically, yeah, I mean, I can't really comment like on the exact like proportion of like um, like off the shelf IPs versus like in house. But you know, wherever we saw an advantage to just like build stuff in house, we would try to do it, especially on latency things. Things that are especially latency sensitive, and I think that's true for across the industry. Um, Honestly, a lot of like the IPs that you can buy off the shelf, like the, we we thought that we could do better on. So then we just like invested the manpower to do so. Um, yeah.
Was there any consideration for uh, like the debuggability of your designs if y'all wrote things in house versus took IP off the shelf, especially if it was
Definitely.
an encrypted IP block? Or did y'all ever have cases where you suspected that there was an error in the IP block, or you just couldn't figure out what was going on with it?
Yeah, I mean, in like the times where we've used like off the shelf IPs, like there were often times where like there would be like some strange error that would pop up, and you just like had very little visibility into what was going on. So that was like endlessly frustrating because you have to like contact the vendor, you have to like write some tickets, like stuff like that. So that's like another reason not to do it, right? Yeah. Whereas like if it's all in house, you can just like look at it.
Sure. It did you kind of were you in a role where you were actually deciding, what vendor provided IP would be used? And if so, it's a pretty different process than just going on GitHub and finding a library that implements what you need. What's kind of
Yeah.
the process for deciding, oh, we need this functionality, let's go look at a vendor for this IP, and then actually acquiring it?
Yeah, honestly, that was like kind of above my pay grade. I didn't really, yeah, like, yeah, I know that like people were constantly in touch with like various like IP vendors and like yeah providers, but yeah, I didn't have to do a lot of that myself, fortunately.
Gotcha. So you were at Hudson River for about 4 years, is that right?
Yeah, like 4.5 years, I think.
Gotcha. And after you'd been there for a while, you decide that it's time to go do something else. What was kind of the process of deciding that, and what did it look like, kind of leaving Hudson River? And before we actually get into what you decided to go do when you were leaving, did
Yeah.
you already have an idea for where you were headed?
I had a few ideas for where I was headed. So, I mean, the process of leaving, I put in my put in my notice. I was very sad to leave because, like, I still have a lot of friends at HRT, and it was a great place to work. I thought, I wanted to explore new opportunities. I wanted to try some like different types of work. So, uh, you know, I had a non-compete, so I knew I had to wait that out a year. And I was initially gonna try joining like another trading firm. But I kind of took my sweet time to just like study, uh, you know, just like read a bunch, just like try to figure out like stuff that just like different industry trends. Like I thought that was like really interesting. I also took like a month or two to just like kind of like lay on my back for a bit, because I was
Right.
working pretty hard. But yeah, I was trying a lot of different things, and then eventually I decided to like um, you know the number of times where you can actually do a startup are like pretty limited, I think. So I think it was something that I always had in the back of my mind that I wanted to try at some point. So that's I decided to just like go for it.
Gotcha. So, you know, maybe a lot of folks are not as familiar with the non-compete status, but that's fairly common in
Yeah,
finance.
super common.
I think that it may be less common now because I believe that non-competes were just recently banned, essentially. But
Yeah, I think some people are like trying to sue over that. I don't know what it's like at HRT or Citadel or anything now, but yeah, like they were super common. And yeah, I think they'll try to enforce them as much as they can. Yeah.
right. And I guess, kind of the logic there is you've had all these experiences, and also, in trading,
Mm-hmm.
the specific strategies you're using are obviously, when it's essentially a race, really valuable, especially in like the short term. So, you kind of understand why they would have that.
Yeah.
Did that end up being, you mentioned you did a number of different things during that period. Did having that non-compete actually kind of perhaps enable you to go and try out a couple different things, since you had to wait that period out anyway?
Yeah, I mean, I think it did, honestly. I know that a lot of people think that non-competes. I mean, this is, I think, just one case in which like a non-compete was actually like good for me to try to like figure something out. Otherwise, like I would have probably just like really tried to just like jump into another job as like quickly as possible.
Right.
Yeah, yeah. I mean, the AI stuff was like a huge thing, and like actually worked on like an AI inference chip. for like training applications. And yeah, it was really cool stuff, and like that was like pretty high. Yeah, I mean, I always want to learn Rust, so I like did some like Rust stuff. But yeah, I think it was good for me to just like spend a few months just like really thinking about like what I really wanted to do next. Because like the natural thing, like once you get into finance and like you're getting free dinners at Nobu and stuff, is just like keep like go to Nobu. But like yeah, I don't know, like give me some time to reflect,
Right,
which is
right.
very useful. Yeah.
Gotcha. And so you eventually decide that you want to go and start a company. Did the decision to kind of go and start a company precede the idea, or did you? Obviously, you'd spent a lot of time in this space of working with the developer tooling around logic
Mm-hmm.
design. Uh, was that something where you were just kind of from the beginning passionate about improving that experience for other folks?
Yeah, I think they kind of went hand in hand. I think the desire to start my own company was always like latent. I would always joke about like dumb startup ideas, things that are too dumb to put out into public. But like yeah, but one thing that like YC tells you is that you should like try to figure out like where your areas of expertise are and like start there. And I just remember that like the process of developing your own chip or just like iterating on designs was just like so painful and so annoying. And you had like this entire we had our own like weird infrastructure that was like built up in order to try to like get around some of it. And yeah, then I just like started talking to other people I knew who were working in chips, and they all basically said the same thing. Yeah, like every company has their own like weird CI/CD testing framework, and no one really loves it, but it's just good enough to get the job done. So yeah, that's kind of how I like came into like those two things came together, like natural entrepreneurial esprit, let's say, and yeah, like this like I don't know, like domain knowledge and something I really wanted fixed. Like I'm working on like an FPGA project right now, to kind of dog food our product a little bit, but also just
Mm-hmm.
like partly for fun. Yeah, and I'm like tearing my hair out, like just like getting stuff running. It's pretty awful, and I want more people to just like be able to pick up an FPGA, and then just like get started, just like trying stuff out. Like it'd be really cool.
Absolutely. I can certainly identify with that, and I'm very grateful for FPGAs because I don't have any sort of formal education in hardware,
Yeah.
but my introduction to FPGAs is what kind of like opened the door to getting experience in it, because there isn't really a parallel to being able
Mm-hmm.
to do hardware development and test out different designs. From in my case my home office, right? And so, but I do see a lot of folks that maybe it's the huge Vivado or Quartus install that
Mm-hmm.
holds them back, or maybe it's going through and learning different terminology, or just like the sheer time that you have to
Yeah.
wait for synthesis, especially in larger designs. Those things can all be massive barriers. So I like kind of the idea of both improving for industry, right? The folks that are already doing this, they already have pain points, but also as part of that, kind of opening up the door to other folks. And it sounds like you've done a number of kind of like solo projects or side projects where
Mm-hmm.
you've been doing your own designs. I'm curious if you think that like an individual is capable of doing like a meaningful chip design, or if you think the complexity has risen to a level where that's like not really a feasible mode of operation.
I mean, I think as it stands right now, be able to do like a really complex design is like pretty infeasible for an individual.
Mm-hmm.
Even playing around with things is like kind of annoying to do. Like, uh, people learn all sorts of insane programming languages for like no observable like use, right? You can look at like Project Euler leaderboards or something, right?
Right.
But like even like the most arcane languages that you see on like Project Euler like have like an easier setup time than like an FPGA, which is like used by like hundreds of thousands of people, right? Um, and which is like sort of crazy to me. And right now, like my goal is that everybody should be able to like start making their custom hardware like on an FPGA, maybe to get started, and eventually maybe like if they find something interesting enough to be able to tape it out. And yeah, I would love to write like some blog posts, like have like educational material on how to get started. Because up until recently, there hasn't been like a lot of like good like literature on how to get started with like designing custom hardware, even if it's like an FPGA. Like maybe you want to prototype like a GPU on an FPGA,
Hmm.
just for fun. Like it'll never be as performant as an A100 or like whatever, but like it could just be a fun thing to get a better appreciation for what's going on, right? That's just like so annoying and painful to get started right now that people are just going to fall. Like people are going to see that it takes like, like 9 hours to install like Vivado and like, like or like whatever, like, and
Right.
they're gonna give up.
For sure. So I want to circle back around to maybe how you've taken some steps to address some of the different parts of the development workflow and maybe some that y'all will in the future. But let's kind of rewind. You mentioned YC. You did go the Y Combinator route with starting your company. I'm curious. I've talked to a number of different folks who have gone through Y Combinator, and there's some folks who come in and they basically have an idea and have done no
Yeah.
work, right? There's some folks who have literally been like building a business for a number of years and they're, trying to scale it essentially. What kind of category or did you fall somewhere in between those two extremes?
Yeah, I guess I would say I'm like a little bit between the two extremes. Like we had like a general idea of like trying to make hardware development easier. Um, we're trying to like that's like a pretty wide front like on which to like to tackle. So we're trying like a number of different things. We're noodling on them for a bit, and then when we came to Y Combinator, we kind of had settled on like the idea of like, you know, like a web-based platform for chip developers to do design verification, right? Because design verification ultimately is where most people spend their time, right? It's just like running the tests, checking results, debugging. Like that actually takes up most like developer time. That's how like you iterate, right? That's how you get like those like iteration cycles down pat. You do place and route like a few times or something, like mostly to check, but like that like things haven't gone horribly awry or something. But your day to day like developer experience, which is like I'm very humanistic in this regard. I want those developers to have like a really great experience, and there's no great yeah, I mean there hasn't been like a great off the shelf like kind of platform for that, which is what we're trying to develop now.
Absolutely. And as part of the process of kind of, starting this company, obviously you already mentioned you found a co-founder. What was the process like identifying a co-founder and, who is your co-founder?
Okay, so my co-founder is Paul. So he was most recently a backend engineer at Cloudflare, and he actually did a lot of like cool testing work at Cloudflare. Like he architected this like test framework that helped them migrate like a really important auth service. He was on the auth team, and the service was securing millions of users. So
Right.
also super important. And you know, he's somebody that I knew like we were roommates in college. Like so, I've known him for a very long time, and um, all yeah, like we just like talk to each other all the time. Like we've been to France and Japan, China and Lebanon with each other. We go on like vacations with each other. So like naturally, when I was like thinking of like doing startup stuff, like I was like talking with him about it, and eventually, it became kind of obvious to me. Like originally, I was going to try to do it solo against everybody's advice. But then I was like, no, that's just crazy. And I have like Paul's great, and started getting interested in hardware as well because like it's like a really cool technology. But uh, it's funny because I take for granted how bad some things are. But if you show like somebody who only has done like software,
Right.
what it's like to try to program an FPGA, it's nice seeing it through fresh eyes. So you can be like, oh yeah, that is pretty horrible. Like, why is this license like a gigabyte long? I don't know, like stuff like that.
Right, right. And you're a fairly technical person and certainly have an engineering background.
Mm-hmm.
You're kind of stepping into a CEO role in the company. What was the decision like? CEO versus CTO, which I believe Paul is the CTO.
Yeah.
And do you really feel like at this point that there's a big distinction, or is being the CEO and being perhaps more like organizationally focused as y'all scale at the company? Is
Yeah.
that something that's kind of like a goal of yours?
Yeah, I mean, right now, like Paul just like handles like almost all of the coding, and then I try to handle almost everything else. Like so everything related to like, just like things as mundane as like figuring out workers' comp and like getting us like health insurance, to doing to more important things like sales, like talking to customers, like that kind of stuff. I'm doing some work to like dog food the product a little bit right now. So doing a little bit of coding here and there. But yeah, I think that like division is like a pretty good. Um, yeah, and I like right now it's like kind of like a dev tooly kind of like framework is like how we're kind of thinking of it. So it makes sense for Paul to take the reins of that a little bit more so than me. Like obviously like I have like a say because like I have like domain knowledge in this. So like we talk a lot. But
Yeah, yeah, no, absolutely. I think that makes a lot of sense, and um, obviously both roles super important. I'm curious, once y'all decided to start this company, what was the process like for applying to Y Combinator, and then once you got in, what was the following, process like after that as well?
yeah, I mean the Y Combinator application is like very simple. Like you have to record like a 1 minute long video explaining like what your company does and your background. That's probably like the most difficult thing. I went through a lot of takes, but even that is like pretty straightforward. And then there's an interview. So I actually applied initially just like solo, which it's like there's no chance I was going to get in solo, I think. And then then when me and Paul were getting more serious about doing the startup, I was like, hey, you should add yourself to the Y Combinator application, because, like it's good for you to think about some of these questions, see how I answered them. And so like, yada, yada. Like, I thought it was like a good idea, like a little exercise. We didn't really expect to get an interview. And then you get an interview, it's scheduled like very quickly. And then you get an answer like the next day. And the interview is like it's pretty basic. You just have to be able to explain what your company does, why you're doing it, like who you're making the product for, just like very simple things. And I think they really value clarity of thought. And if you can kind of get those right, like I'm not, you have a pretty good shot of like getting in. And then after we got our acceptance, like the next day, I got a phone call from Brad Flora, who's our YC group partner. We decided pretty quickly to just take it. And I moved to San Francisco from January, like mid-January to mid-April. And it was a really great experience. I liked it a lot.
Absolutely, and y'all are kind of recently out of the program, and at the end, you had your launch and everything like that. I saw y'all's post on Hacker News, and there's a lot of great comments there and feedback. What was the process like of launching, and what was sort of the milestones that y'all wanted to get in place before you went public with it?
Yeah, I mean, one thing that YC really tells you to do is like to launch as soon as possible. And part of the advice is that you should launch a product even if you aren't embarrassed by the product you launched, then you waited too long. Like that's like classic advice. So we just like set like a pretty high goal for ourselves to launch like in March. Worked on it for like basically like 2 months, just like really it was like a really big lift. And yeah, I mean, it was cool to like just have that like date set. You have to schedule it a little bit in advance. And we had to delay it once because I had to like, I don't know, our website didn't look very good, and I was feeling pretty embarrassed about that. So like I had to get into Framer and like start like moving widgets around. But yeah, like it was really cool to see. And then like that entire day, like when we launched, me, Paul, and our founding engineer James, we just like sat in a room, and then we just cranked out like comments, like answering people's questions. And it was really cool. And we celebrated with like Brazilian barbecue. It was like a really fun time. Like I have very fond memories of that day.
Absolutely. Well, let's actually talk about what y'all are doing and what the name of your company is. Is SiLogy the correct pronunciation?
Yeah, it's SiLogy. It has the capital L in there, which is very like 1990s core. But like,
Right.
I think I'm gonna have to downgrade that to an L in minuscule. But yeah, I mean, I kept trying to figure out like a name, for a very long time. And yeah, naming a startup is never easy. But like two things like I just want to combine together were just like the idea of that like we're doing things with like silicon and that there's a lot of logic that we're trying to verify, right? So that's basically it. It's not very creative or sexy or anything. But it is, and it was important to be able to get like a .io at the very least, right? Because most of those are taken up. I thought about like, I opened up like an ancient Greek dictionary to try to figure out like good words that I could use there. Like I tried all sorts of like wacky things. But yeah, that's just kind of the name we settled on, and I think it flows off the tongue, SiLogy. So yeah, I don't know.
Yeah, as an engineer, I'm a big fan of naming things what they are. So it passes my test for sure. But we've talked a little bit about some of the different parts of logic design, and y'all are really, at least initially, and maybe I can extrapolate a little bit to y'all wanting to own perhaps more of the development workflow. But y'all are really focusing in on verification. And one of the things I noticed when doing some research on the problem space that y'all are trying to solve, in addition to my own experience with it, was on your YCombinator page. There's the video from John from Asianometry, which if I'm sure most listeners already watched this channel because it is absolutely wonderful. But John goes through and describes kind of like this verification gap. And I thought it was really interesting, the framing, and I'm curious kind of like how y'all play into this. It was, I think in 1997, there was this concern about that chip manufacturing, right, was progressing at such a rate and the development tools were not keeping up with it. And so like the productivity was lagging. So essentially we'd be able to manufacture devices or silicon, right, that was more capable than we could actually produce with the tooling that we had. And he goes into a number of different reasons for why that wasn't the case. But then verification comes in and becomes sort of the bottleneck in this process. And I'm curious if why, I guess, verification is the bottleneck there, and if that is the reason that y'all are kind of tackling that as perhaps the first part of improving the development workflow here.
Yeah, I mean, I think so. I think verification has just been overlooked for like a number of reasons. I mean, a big part of it is that it wasn't like a lot of design verification work got outsourced to India and other like lower cost like countries. There's not, and it's also just like not very sexy of a field. It's sort of like you can think of it as like QA, right? Like, like, which is not to say that like the work there isn't like super important or like super interesting. It's just that for whatever reason, it was like not seen as like an important like field. And if you were graduating with like an electrical engineering degree, then if you worked as like an architect, right, you would get paid like 50% more than if you got paid as a verification engineer. So people in the United States, like, no one graduated like top of their class in electrical engineering and went to work as like verification engineers. And I think that for like cultural reasons, it was just kind of like not seen as like that important. Yeah. And I do think that like it is a huge bottleneck because people have just like not kept their eye on the ball. Whenever it comes to, I think custom silicon, like the amount of custom silicon entering the market right now, and is like just like exploding, and like people are really trying to like do creative new things with custom silicon, and yeah, I mean and what's like really grinding people down now is like just like this like verification gap, like the productivity just like hasn't kept up, and I don't know, the entire industry in general hasn't innovated that much recently because like I just think that also like there's like a big gap of people. There's kind of like a lost generation of people who stopped doing electrical engineering in I don't know, like 2008 to like a few years ago maybe, because that's like software engineering, like software engineering salaries like exploded, right? But like hardware engineering hasn't kept up. I think people at NVIDIA now are like pretty happy though. But
Right.
but yeah, so there's all sorts of like weird like I don't know, like macroeconomic reasons that like it just hasn't kept up. And I think more and more people are starting to see that it's like a huge problem, right? I believe like Intel keeps like delaying certain like new chip architectures or whatever because basically because of verification. They keep like finding like little bugs that like get introduced and they can't. They have to like they have to just like I don't know bring a slightly newer version of like an old architecture. But yeah, and I hear that like NVIDIA's like DV like workflow is like very good, so that's like one reason why they've like done so well. So I think more and more people are going to start seeing it as like a competitive advantage to have like a really great verification workflow. Yeah, I mean like startups like have like tons of verification engineers, and it's like a huge overhead for them. And people want to be making new chips. Like it'd be really cool if like uh, if you just have an idea for a chip, you could like spin it out in like a few quarters or something.
Right, right. So in terms of like what is literally the bottleneck, I know y'all are focusing on it. It seems like to
Mm-hmm.
me at least, kind of like collaboration features, and then perhaps just like compute as well, right? Because
Yeah.
y'all are hosting the compute in which the verification runs.
Mm-hmm.
Are those kind of the major aspects of what is causing the bottleneck right now? Or are there other aspects of verification that y'all are tackling or want to tackle in the near future?
Yeah, I mean, like in the immediate term, like we're focusing on like collaboration and like compute because uh, like a lot of times like in chip design, like tests will like take like days to run. Like sometimes like they're week plus long tests, and just getting those numbers down would be like pretty helpful, I think. But also collaboration is like still pretty primitive. There's a lot of times like the state of the art involves like copying over a waveform to your coworker or taking screenshots or like sending a Microsoft Word document in an email. Um, it'd be better if like you could just like tag people directly where like the issues are and be able to like debug like within like be able to send links instead. So that's kind of like one of the big things that we're working to enable. And yeah, in the future, like I mean, this is something that we're also actively working on. It's just like helping people write test benches quicker.
Mm.
You should be able to go from like a spec of the chip to like just even like a list of like edge cases like really quickly, or like things to test for, things to make sure that you cover. Whenever two things are integrated, it'd be cool to like just be able to like inspect like those two blocks and like see like potential interactions that could go awry. And that'd be especially useful because like a lot of times like these integration tests like they're like two teams that work on like two different like blocks, right? And you need to integrate them, and like each has like their own domain knowledge of like the block, but it's hard to like transfer that information around. So that's also like a collaboration thing as well. So yeah, I mean, I think there's like a lot of like kind of low hanging fruit, but also there's a lot of like potential innovation that you could just have in terms of like improving people's like productivity. Yeah.
How flexible are y'all in terms of tooling? I know you mentioned
Yeah.
Verilator on your website. Is it mostly like folks upload their RTL source and
Mm-hmm.
you run the Verilator on it and execute the test benches, or is there the ability for folks to bring their own tooling as well?
Yeah, we support a lot of different tooling in addition to Verilator. Yeah, like we started off just with Verilator because that was what I was most familiar with. But like customers have just been like, oh yeah, we need to like use like some proprietary simulators as well. So we do have like some support for a number of those. Yeah, and
Got
the way that it works is basically you connect. It's like a GitHub app that you just like connect your yeah, you connect your project to it, and then we have like a web UI so that you can that'll just and like our like service will just like run the test periodically. It'll be able to inspect like a YAML file that where you'll be able to like tell it how to like build the test binary and then run it, and then we just like collect all the information and like put it in like a really nice like format for you. Yeah.
Absolutely. So do you see it kind of being like fitting into additional perhaps like GitHub Actions flows that folks would run? And
Yeah.
what are kind of some things that y'all could do that someone could not do in like maybe GitHub Actions or other CI tooling, that's just like essentially raw compute?
I mean, what we're building is really like a chip developer focused workflow. So like basically we're trying to like make sure that chip developers can run as many tests as fast as possible and like just like like it'll run them continuously over across a lot of like different seeds and stuff, not just like on like a git push, but also just like periodically, and like reporting features and like a chip developer focused like workflow, like things like waveforms, rerunning failing tests. Yeah, a lot of these things that like people normally have to like, either doesn't exist at like their firms or their companies, or they would have to roll out themselves with like a DevOps team that like has to like connect a bunch of like tooling together. Yeah, we're trying to make it like a very simple like chip developer focused like workflow, and ideally it'll be something they just like the first thing they do when they get to work, maybe after emails, like open up our tool and like see like what issues like flowed in, see like test results, like see like I don't know like what failed, and like see people's comments and like help with debugging, that kind
Right.
of thing.
You mentioned that some larger companies may have kind of like already rolled their
Mm-hmm.
own systems for this. Do you feel like, I guess, a two-part question? Do you feel like that, y'all are starting out targeting more like mid-size or smaller companies, maybe other startups? And do you
Yeah.
feel like some of the more accessibility of fabbing chips, it's becoming more and more accessible to folks? Do you feel like you're kind
Mm-hmm.
of picks and shovels, as they say, for that kind of movement as well?
Yeah, definitely. I think that we've gotten a lot of traction from startups, especially because, this is tooling that they would have to build out themselves at some point anyways, right? So then they could just get onboarded with us and like we can help them out like, day zero. So, yeah, like, and I think that there's a lot more opportunity for people to be building their own chips. And there's, in fact, a lot of open source stuff like coming out. Like, like there's tiny tape out stuff, but there's also open source like PDKs, which would be cool to integrate with our product at some point. So I think, I just went to like me and our founding engineer, we went to like the like FOSSI Latch Up, like the open
Mm-hmm.
source silicon like conference, like free open source silicon, which is really cool to see like the kind of projects like people are starting to work on. So I think more and more people are getting interested in like open source silicon, but also like custom silicon, and like I would like to be part of that story, that like more people are getting into like making their own chips. Like I think that'd be super cool.
Absolutely. Well, if folks are able to reduce some of the overhead of verification in their design process by using a tool like y'all's, there's also subsequent parts of that: synthesis, place, and route. Right? We've mentioned a couple of these. Are y'all interested? Like, it seems like right now the verification flow would be improved quite a bit, especially if you're collaborating with other folks by using SiLogy or something like
Mm-hmm.
it. But ultimately, then you still have to have the proprietary tooling, or perhaps maybe some of the open source tooling, if applicable.
Mm-hmm.
And that there's still a fair amount of overhead in there. Are y'all interested in kind of like chipping away at that part of the stack? And are there unique challenges with tackling that as opposed to verification?
Yeah, I mean, it would be really cool to be able to like be kind of like this thing that like glues together all of these like different tools and different parts of like the process of developing chips, right? I think my pie in the sky vision is that like once you like in our app, you should be able to have like a flow that like once everything's done, you can like click like add to cart and like send your design to TSMC, right?
Right.
Like I think that'd be like I think that'd be great. In terms of like, yeah, I think developing our own tools, like there would be like challenges for that. You know, there's a lot of really great tooling out there that exists, and a lot of great open source stuff. So I don't want to like like make any really strong predictions like this early, but I'm like I'm very happy about like the potential avenues for future growth.
Sure, right. Another thing that I've kind of observed with folks who get into the FPGA design flow or ASIC design flow
Mm-hmm.
is this desire to maybe like create alternative tools as well. So like there's
Yeah.
one mode of operation where you could go about automating the operation or let's say like hosting tools and that sort of thing. Then you could also go down a path of potentially pursuing developing your own kind of like synthesis and that sort of thing. We already touched on why that can be challenging when you're targeting proprietary bit streams and that sort of thing. But are y'all interested in potentially working in the like more modern HDL space or some of the synthesis process for chips?
Yeah, definitely. I mean, like, I think we'll try to like skate to wherever the puck's going, but like, there's a lot of like different avenues that people are like interested in. Like, yeah, like a lot of cool like higher level synthesis stuff. Like, it's like super cool to me, and it would be great to like be able to like have a way of supporting those like very native, like very easily, and yeah, and yeah. I mean, I'm very excited about like the where like things are going in the space. So yeah, I don't know.
It is another thing that kind of feels like an obvious path or something that I personally would like to see in my own kind of development. We talked about some of the IP blocks and that sort of thing. And obviously there are some barriers, just like some of the barriers y'all ran into at Hudson River or at any of your stops where you had encrypted IP blocks and trying to use those with open source tooling. There's similar sorts of barriers that you could run into with trying to use a product like SiLogy. But one of the things that comes to mind is like if folks are developing in SiLogy and verifying IP blocks and that sort of thing, there's also sort of like a unique marketplace perhaps perspective there where IP blocks could become more accessible. You could get more verifiable properties about them and that sort of thing. Is that something that you could see going after or something you're interested in?
Yeah, definitely. I mean, I think it'd be really cool if like there were a really easy way for people to develop their own IPs and then like maybe just like upload them either open or closed source like to like our platform, and then like you can be able to like buy or download them, license them. Yeah, I think that'd be super cool. I mean, one of my like idea, it's like somewhat of a joke, like for the future is that like maybe like we run a promotion for SiLogy, which is that like if you sign up for like 2 years or something, then we'll throw in a free PCIe core for you or like whatever.
Right.
Yeah, like something like that. And it depends. Yeah, I mean it depends on like what people are looking for. Hopefully there's a lot more like open source like silicon interest, and like people will start open sourcing their IPs, and then maybe we can have like a leaderboard for like I don't know, fastest PCIe core with like the least amount of logic utilization, like yada yada. Like I think that'd be super cool. We have to see whether or not there's space for that in the market, but yeah, I would love that personally, because I hate having to like, it's like, oh man, I gotta have to write my own like driver for this or something, and or like, yeah, like it really does bog people down like when they can't do like very simple things like quickly. And I think that is like a huge barrier to entry for a lot of people learning about custom hardware.
Absolutely. Well, cool. Well, thanks for kind of walking through some of your product there. If folks are interested in trying out SiLogy, how can you go about doing that today?
Oh yeah, what they can do is like so they could go to our website silogy.io. There's like a login button on like the top right, and you could create a free account just to like try it out. You can even create like an anonymized account if you really want to. But if you're interested in like maybe a more full-fledged tour, that's like a very basic version that you can like run some tests on like a very simple Veriliter Hello World. But if you want to look at like some of the more like enterprisey like versions of it, just click book a demo. It'll just be me and Paul. Like we'll walk you through some stuff, or just like shoot me an email. This is dangerous, but like you can just email me at like kay at silogy.io. So. Yeah, I'm a compulsive email checker, so like, if people are like genuinely interested and want to talk about it, like, I'll find time.
Awesome. Well, I'm sure folks would definitely appreciate that. One of the things I kind of wanted to wrap up with our chat today is obviously there's a lot of changes happening in the semiconductor industry right now, both on like the manufacturing side, but also in the workloads. And you mentioned working yourself on kind of like an AI inference chip in some of your free time. I've talked to a few folks both on the podcast and off of it about how these different training and inference workloads are changing the microarchitecture
Yeah.
of some of these chips that are being produced, and that can always lead to different types of innovation, as well as potentially empower some more like upstart companies to make some progress against the behemoths of the industry. I'm curious, just as someone who's in the space, right, has experience in it, is potentially going to partner with or sell to customers in that space as well. What kind of your interpretation of the industry is today, and if you see any kind of like major trends that you find interesting?
Yeah, I mean, I think that in terms of like major trends or like things that I find interesting, yeah, I mean, more custom silicon just like being pushed to the edge, like just like niche forms of compute, like you know, like in like satellites or with like cryptocurrency mining or just like on your phone, like low power things there, robotics. I mean, there's like so much like interesting work being done with open or with custom silicon right now and custom hardware like that. I think it's like super cool. I think a really important thing that people should be aware of though is that like this like the software operability, like software hardware like compatibility is like super important, and that's kind of like one of the big reasons why NVIDIA has like the stranglehold that it does, right? Is that like CUDA is actually like hugely important, and yeah, I think that and one thing that we are trying to enable is like a better way for people to like do this like software hardware like co-design like that kind of thing. Yeah, like I don't know. I think it's super interesting. I think like the new types of like chips that are coming out that people are like coming to us with ideas about are like super impressive and interesting. And I'm glad to see like different companies like try chips.
Mm-hmm.
And yeah, I think yeah, we're only going to see like more and more of it. And hopefully in the near future, we might move back to a future where there are suddenly a lot more like electrical engineers out there, like chip designers, and people who normally would have just like default gone to, like a FANG job or like a software engineering role, like start getting interested in hardware again. And actually, a lot of the people I talk to who are software engineers, they actually did take like, like a CPU's class or something, and they really liked the hardware, but like, some of these like issues were just like, beating them down, so they just went
Mm-hmm.
for the easier route instead.
Sure, right. Well, I think that's a pretty insightful take, and I'm envious in some ways of your position, and that I'm sure you'll get kind of a front row seat to the way things are going, and how folks are using tooling to get there. But I think that we covered quite a bit today. Kay, I definitely appreciate you being willing to jump on here, especially so soon after y'all launched. And I'd love to have you back on again in the future and kind of like do a progress check in on where y'all are at after some period of time here.
Yeah, thanks for having me on. It was like a very fun conversation. Hopefully I didn't violate any like non-disclosure agreements. And yeah, I mean, I hope all of the folks sitting at home had a good time listening. So yeah, I would love to come back on. Yeah.
Absolutely. Well, Kay, have a great week, and we'll talk soon.
All right, thank you.